In this problem, we're going to study the Riemann sum again. So in our case, we want to prove that the integral of x squared dx between a and b is equal to b cubed minus a cubed over 3. Okay, we're going to use Riemann sums, and we're going to use the sample point x sub k equals a plus k b minus a over n. K will be between 0 and n. So the question that we're going to have here is that how can we do this? Okay, we can do it using the definition of the Riemann sum. Okay, so this integral is the same as this limit as n goes to infinity of delta x, the sum between 0 and n minus 1 of f of x sub k. We will see why it is between 0 and n minus 1. And we're going to define the x case as these sample points. And delta x is going to be this difference here. So it's this here between two consecutive sample points. We're going to use the lower sums of these rectangles. And we're going to find the limit as n goes to infinity. The upper sums are the red ones here, and we're gonna focus only on the left or the lower sum. Okay, the process will be the same for the right sums. Okay, the key idea here and the fact that we're gonna need are the sum of the first elements between 1, or the first numbers between 1 and n. It's going to be n times n plus 1 over 2. And the sum of the squares between 1 and n is n times n plus 1 times 2 n plus 1 over 6. Okay. So here, to compute only the left sums, we're going to start from 0. From k equals 0. That means from a, and we will end at n, which is b, but from the left. Okay. To do that, we will start from 0 and we'll stop at n minus 1. The delta x is b minus a over n, and the f is going to be x squared. So when we do f of xk, it's going to give us a plus k times b minus a over n squared. Now, when we expand this one, we're going to have the following. So it's going to be the limit as n goes to infinity of this sum here. So of the sum of this expansion. So when we do the square, so when we compute the square, we're going to have a squared plus 2a times b minus a times k over n plus k over n times b minus a squared. And I had to simplify this one because we don't want to spend a lot of time on algebra. So now the sum of the square, the a squared between 0 and n minus 1 is going to be n a squared. And here this sum is going to be, so we first take 2a times b minus a over n outside of the sum, okay, because it doesn't depend on n, and we only sum the case, okay, between 0 and n minus 1. The same thing for here. We take b minus a squared times over n squared, and we sum only the squares, and we use these results here. Note here that we stop at n, but here we stop at n minus 1. Look at the index. So here we got this sum here. It's going to be n a squared. This sum is going to be 2a times b minus a over n, and this sum is going to be n minus 1 times the next one over 2. This one here is going to be n minus 1 times the next times their sum. It's going to be n minus 1 times n times 2 n minus 1 over 6. Okay, once we do that, we can compute the limit. I'll finish it here. Okay, now we see that, okay, so the limit as n goes to infinity. So here I'm going to have b minus a. I will enter the n inside. It's going to be n a squared over n plus a times b minus a times n minus 1. I had to simplify by these two, so it's going to be n squared. And here it's going to be plus b minus a squared times, let's make it over 6, times n minus 1 times n times 2n plus 1 times the n from here, and the n squared is going to give us n cubed. Okay, now we'll take the limit. So the b minus a is a constant. So this one is a constant because n over n is 1. Okay, so it's a squared. And here the limit is going to be 1 because n times n minus 1 over n squared is just 1. So we have a times b minus a plus this one here. The limit here is going to be minus a squared over 6 times this one here, n minus 1 times n times 2n minus 1 over n cubed. It's going to be 2. The limit is 2. Okay, therefore we have b minus a times a squared plus ab minus a squared plus b minus a squared over 3. Okay, I'll take the 3 outside, so I'm going to have 1/3 b minus a, and I'm going to simplify. So here I'm going to have only ab, but I'm going to multiply by 3 to make it easier, because not to make it easier, so I need to have this 3 here. So so this a is gonna go. I need to multiply by 3 here because I have to take it. I took it outside. Plus b squared minus 2ab plus b squared. Therefore, I have 1/3 b minus a times a squared, not b squared. So it's a squared plus ab plus b squared. Okay. But this one is a very famous, remarkable identity. So it's going to be 1/3 b cubed minus a cubed. We know this one. Very famous. Therefore, this is my integral, b cubed minus a cubed over 3. This is the limit. Therefore, the integral between a and b of x squared dx is b cubed over 3 minus a cubed over 3. And that's what I needed. Okay? So it's just some simple algebra. And using the lower limits and taking the sum of the squares and the first elements, and we get the result. For the right or upper limit, it's the same work, and we're gonna get the same limit. I will not compute the right sums, these ones that I have in the other side. So these ones here, I will not compute this one in red. The same process we'll do exactly the same process except for the index. Okay, and we're gonna get the same limit. You can go ahead and do it, and this will end our proof. And if you have any questions, any comments, please comment, share, and subscribe. And thank you very much for watching the videos. Thank you.